Asignado en la opción señalada, institución de asignación UNAM.
¡Sí quedé! ¡Sí quedé!
El sueño se cumplió. Ahora formas parte de la comunidad universitaria y puedes acceder a las becas que Fundación UNAM tiene para ti. Conoce nuestros programas en www.funam.mx y en nuestras redes sociales.
Asignado en la opción señalada, institución de asignación UNAM.
¡Sí quedé! ¡Sí quedé!
El sueño se cumplió. Ahora formas parte de la comunidad universitaria y puedes acceder a las becas que Fundación UNAM tiene para ti. Conoce nuestros programas en www.funam.mx y en nuestras redes sociales.
Asignado en la opción señalada, institución de asignación UNAM.
Sí quedé.
El sueño se cumplió. Ahora formas parte de la comunidad universitaria y puedes acceder a las becas que Fundación UNAM tiene para ti. Conoce nuestros programas en www.funam.mx y en nuestras redes sociales.
Bienvenidos al ciclo de conferencias de investigación Universidades por la Ciencia, organizado por Fundación UNAM, el Colegio Nacional y el Consorcio de Universidades por la Ciencia. Les agradecemos mucho el interés y que nos acompañen. Y el día de hoy tenemos una conferencia muy especial a cargo de la doctora Nancy Knowlton, quien es Center Chair Emerita en el Museo de Historia Natural en Washington, D.C. Bienvenida y gracias por aceptar la invitación, doctora Knowlton. Welcome to the University for Science seminar series organized by the UNAM Foundation and the Universities for Science Consortium. Thanks very much for joining us and for the interest. And today we have a very special conference by Dr. Nancy Knowlton, who is the Center Emerita in the Natural History Museum, in the Smithsonian Natural History Museum in Washington, D.C. Thanks very much, Dr. Knowlton, for accepting the invitation. And Dr. Nancy Knowlton has a very distinguished career studying the life at the seas. She has several very interesting books, and she has been in the Smithsonian Museum for a long time, organizing a large number of research projects. And previously, she has been in the Yale University, in the Smithsonian Center in Panama, in the tropical forest of Panama. And Dr. Knowlton is a member of the National Academy of Sciences, and also the Academy of Arts and Sciences. And Dr. Knowlton has been studying the corals, coral reefs, and the effects that were producing globally, affecting the different ecosystems. And today she will present a very interesting talk, joining all these different aspects and what we can expect in the near future. If it's a scenario of doom or a hope and it will be a very interesting conference. And we are joined by the president of the UNAM Foundation, Dionisio Meade, the executive director, Araceli Rodriguez, the president of the Consortium for Universities for Science, Araxi, Urrutia, and Constantino Macias, who is in the Institute of Ecology in the National University, and is also the chair of the UNAM Canada. And we welcome your comments and questions through the different platforms in the consortium. Muchas gracias y les invitamos a que nos hagan preguntas, comentarios a través de las redes de Fundación UNAM y del Consorcio de Universidades por la Ciencia en inglés y en español. The seminar series is also part of the International Year of Basic Science for Sustainable Development of the United Nations and UNESCO. And this year, it has been transformed into the decade of sciences for sustainable development. And research like the one presented by Dr. Knowlton is fundamental for understanding what is happening in our planet and the life with, well, we are just part of the life in this planet, although we have the capacity to affect it. Muy bien, entonces, pues muy bien, bienvenidos nuevamente, and vamos a comenzar. Nancy, the floor is yours, and thanks very much again for accepting this invitation. We are extremely happy, and we look forward to see you here in Mexico. So,
yes. Muchas gracias y buenas tardes. Thank you very much for inviting me to give this seminar. It's a real pleasure to be able to reach out to colleagues to my north and to my south, east and west. So what I'll do is share my screen and start. Here. Can you see my, oh, yeah, let's see, wait, one more thing. There. Okay, that should be the first slide of my talk. Yes, good.
yes,
So
that's very good.
great. So what I'd like to do is share with you some thoughts about the way we think about the future environment of our home planet Earth. And I would like to frame it in the context of two different ways of looking at it. On the one hand, doom and gloom, that everything is bad and getting worse. And on the other hand, as hope and change, the possibility of making forward progress and actually improving the situation rather than having everything continue to get worse. So this is a contrast I think we see often, not just in the environment. We see it in political campaigns often, certainly right now where I live in the United States, whether you choose to focus on what's wrong or what's right. And my general point is that although there's plenty of reasons to be discouraged and angry about the state of the environment, there's also many positive things, and that by shining a spotlight on some of those positive things, we're more likely to make things even better. So that's really the general theme, and then I will give you some examples which I hope illustrate that point. But first, let me simply say that I didn't start off always thinking about hope and change and a positive way of thinking about the environment, because my entire research career, which began in the 1970s, a long time ago, has seen really an ocean of bad news. I'm a marine biologist, and so I'll start with some marine examples, in particular how I started my career on the north coast of Jamaica. And this is on the left-hand side, you can see a picture that I took as a graduate student in the mid-1970s. That's what the Discovery Bay, Jamaica looked like back then. That reef that you see is covered with living coral. All those branches are live staghorn corals, Acroporus cervicornis, and they're big heads of coral of various kinds. And the bottom had more or less about 70% live coral when I began my graduate career. Now, we knew even then that that wasn't a pristine reef in any sense. It wasn't in perfect condition. And how we knew that is what you don't see in that picture, which is really any big fish at all. They were up in the right-hand corner. You can see some small plankton-eating fish, and there are a few fish grazing on the bottom, again, small fish that are at most 5 centimeters long. But all the big fish, all the groupers, the big snappers, the sharks, of course, no turtles. There was nothing really big in the water. So we knew the corals were in great shape, and we just assumed that the fact that the fish were mostly gone really didn't matter. And that turned out to be a terrible assumption, because within 10 years of my beginning my career, the reefs on the left looked like the reefs on the right. That's really the same location, Discovery Bay, Jamaica. And although there's a little bit of living coral there, most of it has died and even by 1985, most of it had died and be replaced by seaweed. So this really was a transition, an ecological transition that framed how I thought about what was happening in the ocean. And as a result, I and my husband, Jeremy Jackson, also a marine scientist who I met in Discovery Bay, spent many, many years, decades really, talking about all the bad things that were happening in the ocean. I would give talks entitled Coral Reefs, Canary in the Environmental Coal Mine, just to indicate that reefs were a leading indicator, if you will, of a collapse of many other ecosystems around throughout the ocean and on land as well. And my husband gave a TED Talk, How We Wrecked the Ocean, which has been viewed many hundreds of thousands of times, talking about all the different bad things that have happened to the ocean as a consequence of human activities. And in the picture you see on the left of me is actually an artist's take on my picture. He found a picture of me on the internet, and then he made it acidic. I had been talking a lot about ocean acidification, and so he acidified my skin, and that's why the picture looks like it does. But I am an acidified scientist there on the left. So the story from Discovery Bay was pretty dramatic and very depressing. But as the years unfolded, it became clear that it wasn't just Discovery Bay, it wasn't just coral reefs, it wasn't just the ocean, it was really the entire planetary ecosystem. And so more recently, there have been books published, for example, on the left about climate change, The Uninhabitable Earth by David Wallace Wells, and then by Elizabeth Colbert, The Sixth Extinction, about biodiversity loss. So we've seen these sort of two narratives running side by side. One, the catastrophic changes in climate, and also the catastrophic losses in biodiversity. And as a function of these twin crises, it's led people to say that really there's nothing right happening on the planet at this point. Now, of course, there's a lot of truth to these grim descriptions of what's been going on. In fact, there was just a recent report saying we'd lost basically 3/4 of all biodiversity in the last 50 years, and they are talking about this loss now during the biodiversity conferences that are taking place. And it's incredibly important to understand the scale and scope of the damage that's occurred. On the other hand, if you talk only about all the bad things that are happening and you don't talk about any examples of positive things or potential solutions, it's more likely to lead to apathy rather than action. And I think this is really nicely captured in this New Yorker cartoon where a man is sitting on a couch talking to his friend, and he says, making a difference doesn't make a difference. That is really the mindset that you wind up with if all you focus on is all the things that are going wrong and you never focus on any of the possible solutions to the problems. And so that's what really led to my search for solutions. It came about after, as I say, years of talking about all the bad things that were happening. I was teaching students at the Scripps Institution of Oceanography, and I came to realize that we were running essentially what you could think of as medical school for the ocean. But what we were really doing was teaching them to write ever more refined obituaries of the ocean. And I came to think about the fact that, well, in medical school, you don't just train future doctors to write obituaries, you train them to come up with solutions to people's medical problems. And similarly, we needed in the environmental realm to have a similar focus on what we could do to make things better. And that led me to start a campaign of really a series of seminars called Beyond the Obituary: Success Stories in Ocean Conservation. This ultimately led me to meeting other people of like mind, and we launched a Twitter campaign called #OceanOptimism, where we use Twitter to flag examples of things that were going better than expected. And this is an example of a post about how the possibility of bringing abalones back to California that was flagged in that particular post. But if you go on Twitter, you can find many, many examples of things that are going well under the #OceanOptimism flag. And then ultimately, when I moved to the Natural History Museum in Washington, I started with colleagues an initiative to focus not only on the ocean, but also on other aspects of conservation and climate success, which led to a series of summits, what we call the Earth Optimism Summit, which was done in Washington, also in partnership with Oxford University and Cambridge University and various other places around the world. So this has grown from a sort of personal obsession to a much, much broader movement. And what I'd like to do now is just give you some examples of places where things, even though we tend to think of all the bad news, where things are actually have done better in recent years, thanks to human actions. So here, the first one is about the recovery of sea turtles. I'm sure many of you listening are well aware that sea turtles have many threats, including hunting for their meat, but also digging up sea turtle eggs. That's certainly a problem in Mexico and in many parts of the world. But there have been grassroots efforts and government regulations which have really helped to reduce the amount of mortality of sea turtles. And actually, in addition to hunting the sea turtles and their eggs, also they get caught in fishing nets as well. And the result of all of these different efforts operating on various scales has been, in many places, a dramatic increase in the sea turtle populations, which you can see on this right-hand graph. And these are just two examples of the hawksbill turtle in Mona Island off the coast of Puerto Rico and the leatherback turtles in the Florida and the US Caribbean. You can see populations recovering from almost zero to thousands and thousands of individuals. And indeed, when you look look sort of overall, a really nice summary by Valdivia and others in 2018 showed that about 2/3 of all sea turtle populations were actually increasing rather than decreasing. And when I give this talk, it's often the case that even now, many years after that that summary report was made in 2018, people are largely unaware of the fact that many sea turtles are increasing, sometimes very, very dramatically. And this to me is an example of why it's so important to talk about what's worked and what might work, as well as the failures that we've had. Let's see. Another really dramatic example of recovery is the recovery of the California sea otter. These very charismatic creatures used to range from, actually, I believe Mexico all the way up into Canada, the Canadian coastline, and they were hunted to near extinction. In fact, the southern population thought to be entirely extinct until a small population of a couple dozen individuals was found off a remote part of the California coast. Now, however, the recovery has been really dramatic, as you see in these charts, and it's gone from near extinction really to a tourist attraction. And what's really important about this recovery is that it's not only good news for the sea otter, but it's good news for many aspects of the marine habitats along these coastlines, because the sea otters control, as top-down predators, control the things that eat kelp and other seaweeds. And as a result, you have much healthier kelp beds when sea otters are present, and actually many financial benefits to people as well. Another example of things that we've been doing more and better in the last couple of decades is, in addition to protecting species, is protecting spaces. And some of these are large and far away, the classic example being the Ross Sea in Antarctica, where one of the largest marine protected areas on the planet exists. But also some of them can be small and nearby, and in fact, in very densely populated places. And what you see on the right is a picture I took in the Mai Po Sanctuary. It's an estuarine system, which is wedged between Hong Kong and Shenzhen. So many, many millions of people are nevertheless coexisting with some important populations of migratory birds and other marine creatures, including some that are endangered. So this is an example of a successful protection effort, despite the huge numbers of people in very close proximity. Some of these marine protected areas have had clear benefits, not only to the organisms being protected, but also to fisheries and therefore the people that depend economically on fisheries. This is an example from the Northwest Hawaiian Islands. And what this study published in Science in 2022 showed was that catches, as a result of expanding the marine protected area around the Northwest Hawaiian Islands, catches of yellowfin tuna increased by up to 54% and big-eye tuna up to 12%. So these have had real fisheries and therefore economic benefits in addition to ecosystem benefits. On a smaller scale, there's been a lot of studies showing that local cooperatives can be very important in terms of managing the ecosystem in a way that's beneficial for people and for the ecosystem itself. These are often called territorial user rights for fishers or TERFs. Some of the classic examples that were studied were in Chile, where it was shown, as you see in that graph, that a turf, this is a fishery for what's called the loco, sometimes called the Chilean abalone, although it's actually not an abalone, but it's eaten in a way that abalones are eaten. And you can see there that if there's open access, that is no control, the number of these snails is very low, but in either turfs or in no-take marine protected areas, which is the NT-MPA bar, both show comparable densities of these Chilean abalones, and in the case of the turfs, these are managed entirely by local cooperatives who get together, the members get together and decide the appropriate level of harvesting. And these turfs are also actually quite widely used in Mexico and other places around the world. Another example of a recovery is that of the Nassau grouper in Little Cayman Island and also in Cayman Brac. So these are two small islands in the Caribbean. The Nassau grouper used to be one of the most abundant groupers in the Caribbean, but it has the habit, along with many groupers and snappers, of all having large numbers of them congregate at certain times of the year in order to spawn. And what you see left on that video is, in fact, an aggregation of spawning snappers and groupers. And the reason that's a problem, it's very efficient for reproduction, but it's also very efficient for fishing. And so what happened was, over the years, fishing communities would know that these aggregations would take place at particular times and places, scoop up all the fish, and the result was a predictable collapse of these populations, to the point where Nassau groupers, which were one of the few common predators when I was in Jamaica in the 1970s, over the course of decades became listed on the Endangered Species Act. So what happened in the Cayman Islands was a recognition that we had to protect these spawning aggregations in order for the populations to recover, and that's exactly what has happened. The protections are in place, no fishing is allowed, and there are actually other regulations associated with the management of the Nassau grouper. And the result has been a steady increase over the years in Nassau grouper numbers, thanks to this protection. We were also making some progress in reducing bycatch. The example on the left is from the banning of gill nets near shore off the California coast. You can see that happened. This is an example of one particular fish species heavily fished, and it was listed as protected in 1980, but then the gill nets were banned in 1994. The reason it was important to ban the gill nets is that the large females would come inshore to breed, and then they would get captured in the nets. And of course, what you don't want is a fishery where you're capturing a lot of females full of eggs, which will produce the next generation of fishes. And so what you can see is the increase in the number of fish per survey, which you see in the lower graph, but on the upper graph, the catch per unit effort, which means that fishers are getting many more fish each time they go out to fish than they would beforehand. So the big increase in the catch per unit effort from 1995, about when the gill net closure took place, and that data actually stops in 2004, but these trends have continued. There's also been a lot of work trying to figure out how to reduce other kinds of bycatch, especially in the high seas. One particular example is the use of these illuminated nets, which was, it was reported that in 2021 that they resulted in a really dramatic decrease in bycatch as a function of having these lights identify the nets so that organisms wouldn't swim in them. Turning from sort of protection of individual species or groups of species or ecosystems, because of the extent of the damage that we've done over the course of decades and really centuries, we're really in a position where we can't just protect things and try to do things better. We actually have to take a hand at times in actually actively restoring ecosystems. And in fact, we are currently in the midst of the decade of restoration that organized by the United Nations. You see here some images taken by the Zoological Society of London in the Philippines, and shows you reforestation effort for mangroves and what it looked like in 2007 when it started, and really a very short time later, just 5 years later in 2012, the recovery of, or the beginning of the recovery of, a full-fledged mangrove ecosystem. And one of the things that's really important to recognize, if you look at the average annual deforestation rate, it has dropped dramatically in recent years. And part of that is a function of protection, and part of that is a function of reforestation. Similarly, seagrass restoration efforts have come a long way in the last several decades. This is a study published by Orthodol in 2020, I believe, in Science Advances. And they were working on the coast off of Virginia, and sort of in the middle of the Atlantic coastline of the United States. And what they did was develop a way of collecting seeds and distributing them very efficiently. And as a result of that, they wound up distributing 70 million seeds and reforesting 9,000 new acres of seagrass. Sorry, that's not in hectares. But this is a fairly substantial effort. And so the seagrasses are definitely expanding. But what's really interesting about this restoration success is it's also resulted in the capture of carbon and nitrogen into the sediments, and an increase in the number of commercially important invertebrates and fish. So again, this is a restoration conservation success, which has benefits not only for the ecosystem in a narrow sense, but also much more broadly for other things that people care about. And you can see a similar pattern on a much broader scale in terms of looking at European seagrasses, which have definitely, they went through a very bad period, dropping from the 1950s quite substantially into the 1970s and 80s. But in more recent decades, those numbers have gone up. That's why I think it's really important when you see these statistics of how much we've lost in, say, since the 1950s, to break those data up in a way that allows you to see the trends, not only overall, because we're still in a very bad state, but how things were before we started to work on the problem versus how we are now that we've in more recent decades when we started working on the problem. So as I say, in some cases, you can see in this particular example, the changing, we've actually gotten back to the 1950s in terms of this particular metric. We've still got a long way to go in almost every situation. There are some examples where things have completely recovered. But the point is, if you change the trend lines, it's really an important indicator of a strategy that's working. So here's some general data from a paper that I was part of in 2020, published in Nature, on how the improvements that have occurred in the ocean broadly. And these two particular graphs show fish stock trends on the left and marine mammal trends on the right. And what is important to look at is the red are problem areas, but the blue are increasing metrics that are increasing, and the sort of grayish beige is areas where there is no net change, so at least things are not getting worse. And as you can see, there's quite a lot of blue and quite a lot of gray. Now there's still plenty of red, including in certain locations for fish stocks, but this is a clear indication that some of the things that we've been doing around the world are working. And in this same paper, we looked at the number of sort of the efforts to protect and restore areas. And so you can see on the left the percentage of the ocean covered by marine protected areas through 2020, a very dramatic increase, particularly since about the year 2000. And similarly, in restoration of a variety of different marine ecosystems, mangroves, seagrasses, salt marshes, coral reefs, kelps, and oyster reefs. And some of them really quite spectacular. You can see mangroves on the top, which I mentioned before, are really exemplary in this regard. Here, closer to home in terms of restorations, this is a stream that's actually very close to where I live. It's just really a 10-15-minute drive. And in rivers in many parts of the world, including in New England, which is where I'm located, rivers have been dammed, both big dams and small dams, for a variety of purposes. And the result has been the blocking of access to spawning areas by species of fish that move back and forth between rivers and lakes and the ocean. And some of those fish are very important in terms of providing the sort of sustenance for all sorts of higher parts of the food chain. And one particular example are alewives, which you see here. Alewives are small, oily fish. They spawn in lakes, but they have to travel up rivers to get to the lakes, and then they go back to the ocean. And when they're in the rivers or in the oceans, they're the food of many, many different higher level predators. And their numbers had collapsed thanks to the widespread damming of rivers, large and small, in the main landscape. And here you see what happened when the Kennebec River dams, the Edwards Dam and the Fort Halifax Dam, were removed. You see those located there. So the bars show the numbers of these fish. And as you can see, and this only goes through 2018, I think now the numbers are over 6 million. We went from essentially no alewives swimming in the Kennebec River to over 6 million. And this has had huge potential importance for the recovery of the entire Atlantic marine ecosystem in this part of the world. You can see a similar example of a really dramatic return in European wildlife. Here you see a lot of difference, the percentage increase of a variety of different species, beaver, bison, seals, bats, goats, et cetera, all the way down. This comes from Our World in Data, which is a very interesting source for information on when to find things not only getting worse, but getting better. And the beavers are a particular champion. They have increased from very small numbers, from just over 1,000 to 1.2 million, which represents a 16,000% increase in their numbers. But there are many other species on this list which have shown substantial increases thanks to a variety of different kinds of efforts. Here's another example of a real recovery, which is Gorongosa National Park. and this is in Africa. And it wasn't an area of enormous human conflict, civil war, but it has changed from a battlefield to a conservation success, with about 95% recovery of large herbivores, a big rebound in predators, particularly lion numbers, and the successful reintroduction of a highly endangered species, the wild dog. So this is, again, this was a particular success, which was actually driven by private philanthropy, including one individual who has given extremely generously to help restore this ecosystem. Sometimes getting things to improve requires not just protecting things or putting things back in the system, but actually removing things. And one of the big examples are invasive species. And particularly on islands where it's easier to actually entirely remove invasive species, we've had some really dramatic successes. So here you see two examples for where we've had really remarkable successes in removing rats. One is Palmyra Atoll, which is a tropical atoll in the central Pacific, and the other South Georgia Island, which is just north of Antarctica. And in both cases, it was possible to remove all rats from the system, resulting in a tremendous recovery of seabirds. And in the case of Palmyra Atoll, it's actually been shown, not so much Palmyra Atoll per se, but many coral reefs in the Indian Ocean and presumably elsewhere, that recovery of seabirds not only helps seabirds, but it actually, the nutrients that seabirds bring to the island and deposit on the island through their guano then leaks back onto the adjacent coral reefs. And particularly in places where the waters are very nutrient poor, this actually results in a healthier reefs in addition to healthier seabird colonies. So these are two really dramatic efforts that people have made to reduce and eliminate invasive species. And these are just two of many, many examples, as it turns out. Now, I'd like to turn a little bit to sort of the climate and some of the successes we've had in terms of sort of atmospheric protection and recovery. And perhaps the classic example is the role that human efforts to reduce chlorofluorocarbons has had on the recovery of the ozone hole. So you see, again, from Our World in Data, the emissions of compounds that deplete ozone from 1986 to 2021 has been a huge dramatic drop in those. And as a result, it's of this Montreal Protocol, which really created the global policy structure to allow this to take place. We've had a real recovery of the ozone hole. It's not entirely recovered, but it's definitely almost recovered, on trajectory recovered. And it's been estimated that this recovery will result in 2 million fewer skin cancers by the year 2000, which is, so this shows, again, not only a benefit to the environment and all the organisms that are affected by the reduction of the ozone hole, but also to people's health. Oops. So here's another example where we've really starting to see dramatic changes, and that's in the growing uptake of renewable energy. On the left, you see my house, which has solar panels on it and an electric car in the driveway. And I live in Maine, which is right, for those of you who don't know, this where the states are in the United States, is right below Canada. So it's in the top northeast corner of the United States. We have very short days in the winter and very cold winters. So if solar power can work here as it does for us, it can work essentially anywhere. But of course, it's not just solar power, it's also wind power and other forms of renewable energy. And in fact, wind power and solar power together are resulting in increasing share of the electrical consumption around the world. So part of this is, in fact, a large part of this is, well, part of this is due to the increasing sophistication and effectiveness of the technology we have. And this has in turn then resulted in a collapsing cost for renewable energy, such that the things we need for a green energy transition are now much, much more affordable. When this work began decades ago, you really needed strong government subsidies in order to make the the sort of the financial business model work for these kinds of energy. And now these are the cheapest forms of energy in most parts of the world. So you see on the left, you see solar in yellow and wind in blue, both dramatic decreases in cost per kilowatt hour. So that by 2018, they were the least expensive per kilowatt hour of any possible source of energy. And on the right, you see another critical part of the renewable energy transition equation, which is the price of batteries, which between 1991 and 2018 has fallen by 97%. So together, these have really driven what is now a revolution in the renewable energy situation around the world, which sets a stage for places even currently that have low levels of renewable energy to really step up and make them a part of their grid system. Related to the sort of in a similar vein is the share of new cars that are electrically driven, that's electric vehicles or hybrid gas electric vehicles. And here you see the data for a couple of different countries and also regions. So it's still, these numbers are still pretty low, but what's really interesting is some of the places where it's succeeded. And really one of the most exceptional situations is in Norway, where 80% of the new cars sold in 2023 are electric vehicles or hybrids, and in fact, mostly battery electric purely rather than plug-in hybrids. Now, there's a lot of variation. The United States and Mexico, which I showed here by comparison, are nowhere near Norway. And the result, it's really interesting to think about what Norway did to launch this kind of transportation revolution. Basically, they made it they provided financial incentives to in the way of sort of low or no taxes on electric vehicles, and also parking fees and ferry fees in other places where the government charges for the use of cars. They reduced the fare or eliminated the fare for electric vehicles. And they've even provided incentives so that people would get money if they turned in their gas cars. Now, in fact, it's so successful in Norway that they don't need these incentives, and they're sort of gradually being rolled back. But they were a big part of the initial success, and I think it's a lesson that can be learned in other countries as well. China is making great strides in this direction, and as I say, some parts of the world, my country included, need to do a lot more. But because the electric vehicles themselves are also, because of these other things that I talked about, decreasing in price, they're definitely a superior car in many ways. So once the charging infrastructure and the price situation are fully resolved around the world, then there's really no question that electric vehicles will be the cars of the future. I want to turn a little bit now to the benefits to people as associated with improving environmental situations. I've touched on these in some of these examples, and I want to give a few more explicit examples. One concerns sort of improvements to human health and dignity and just general well-being. This is an example from a company called Sanergy, which is based in Nairobi. And the founder of that company recognized that in slum areas around the world, it was never going to be possible to lay sewer pipes to get everybody connected to urban or suburban sewer systems where the water could be treated. And as a result, in the absence of some other strategy, most of the human sewage pollution was due to the fact that most people had no access to places to use the bathroom other than the kinds of shacks that you see in this image. And the waste, of course, from those shacks went right into waterways and out into the coast. So they created essentially small, low-cost, clean facilities for people to use. They created them in a kind of small business model where individuals would run them and make an income from running them. But in addition to the economic benefits to particular individuals, and of course, the dignity benefits to everyone using a clean and safe facility, the waste is collected, brought to the outskirts for composting, and then distributed to organic farms around Nairobi. So there are a whole series of different kinds of benefits associated with the efforts of this company. Here's another example of organization called Health and Harmony. It's set up by Canary Webb, who realized that she didn't really she was working in Indonesia, and she actually didn't know why there was a huge amount of deforestation. She wanted to know, okay, what is the root cause of this deforestation? And so she actually spent a year listening, what she calls radical listening, to people who told her that really the reason they cut down trees was in order to earn enough money to pay for doctors and medical expenses for their families. And so she set up this organization called Health and Harmony. She brought in doctors from a variety of places. She also taught people in these villages how to do organic farming. And the result of this entire effort, which is now spread well beyond Indonesia, is a 70% decline in deforestation, a 90% decline in the numbers of families that are depending on logging, and really importantly, a 67% decline in infant mortality as a result of her efforts. So it's a clear example of a win-win-win. Here's another example in Brazil that a recent study, 2021, that compared a variety of sort of attributes of human well-being and access to services as a function being in protected areas, inside and outside protected areas. And these are shown in the map on the left. So the green areas where communities were fully empowered to manage these resources and protect them. And the red area is not empowered, and the yellow sort of in between. And if you look at places inside and outside these protected areas on the right, and the inside the protected areas is in purple, you can see access to things like sanitation, primary school, electricity, healthcare. All of these things have been dramatically improved together with the improved management of the forests in the protected areas in Brazil. And then here's an example of West Africa. This is a sort of an example in progress, I would say. The problem here that was being addressed was the fact that in agriculture that was dependent on a lot of fertilization resulted of using fertilizer, resulted in all this excess nutrients going into water, which resulted in a lot of vegetation growing, which increased the number of snails, which led to outbreaks of schistosomiasis, which is a very serious human disease. And so what they discovered is that they removed the vegetation, that not only did the amount of snails go down, but also that vegetation could be used both as fertilizers for crops and also food for their animals at a rate that was far, far cheaper than the actual commercially available fertilizers and food inputs to their livestock. And so this is an example where human health, water quality, and economic well-being were all improved at the same time. So I want to close with a few examples from Mexico. This is the one I know best as a marine scientist. It's a really classic example of Cabo Pulmo National Park. This was a case where really a small village that was, in a way, almost an extended family, got together with the help of scientists at local universities, realized that their fishing practices were stripping all the fish out of the waters in an unsustainable way, which was going to lead them ultimately to destitution. They got together, they created a small protected area outside Cabo Pulmo, which has since been turned into a national park in Mexico. And what you see here is the change in terms of the ecosystem between 1999 and 2009, between open access areas where there's no change in terms of the number of, but the biomass of fish, which is what's being measured here. Even in government protected areas, which were not well protected, there was no change, but in the Cabo Pulmo National Park on the right, a dramatic increase in the biomass of fish, and particularly in the top predators, those big things, which I mentioned right at the outset, tend to disappear when you have any kind of overfishing. And this recovery has led to a huge increase in tourism, a dramatic increase in incomes, and so that now if you do a Google search as a potential diving tourist for Cabo Pulmo, you see all sorts of possible options. So the economic basis of their well-being is much more widely distributed and not dependent solely on fishing. So that's perhaps the best known example of a successful marine protected area, really anywhere in the world. It's a story that people in the marine sciences tell on a routine basis. But I decided just in preparation for this talk, just to look for a few examples. So of what things are happening recently in Mexico. So I went on Manga Bay, which is a good site for environmental news, both good and bad. And the three most recent studies were actually about teaching, sort of rewilding jaguars by teaching them how to catch things, effort to fight illegal fishing and thereby revive species, and also the local cultural leaders working with scientists to revive ecosystems. And you can pursue these if you want on Manga Bay. And then another website which actually focuses on good news, Reasons to be Cheerful, which is always interesting to look at. Two more examples from 2024, one on a big Mexican electrical operation that is cooperating with fossil fuels, and another one about floating gardens as models for sustainable farming. So I've given you a lot of examples to give you a sense of the diversity and scale of these efforts. But I want to return to a point I made at the very beginning, which is that I don't want you to ignore the bad news. There are huge setbacks and there are huge trade-offs that are sometimes taking place, including even, say, for renewable energy, where poorly sited solar farms, for example, can lead to a lot of deforestation. And of course, the horrifying projections about the future are very, very real. These are just two examples of things that at the beginning of my effort to look for success stories, I used to talk about seagrasses, the recovery of seagrasses in Tampa Bay to 1950s level, and the removal of manatees from the endangered species list in the United States. And now, seagrasses have been declining in Tampa Bay in the recent years, and manatees are starving to death in Florida. So there's the whole conservation career strategy sort of mindset. It has to be one of sort of being, just determined to push forward, even when things seem to not be getting better. If they seem to be getting worse, or things that were getting better are now getting worse again. It's like, it can be a 2 steps forward, 1 step backwards, or sometimes 1 step forward, 5 steps backwards. And that's just the way conservation works. So you can't ignore those things because you have to know where the problems are. But on the other hand, if you ignore the things that are working well, you lose the ability to be inspired by those examples, to learn from those examples, and to motivate others into joining you in an effort to make the planet a healthier place. And so what I'd like to close is this quote, which I think is really is one strategy for sort of trying to sort of pull together in your mind all those different kinds of things that are going on. It comes from Max Roser, again, Our World in Data. So what he says is that, the world, he says, you can have these 3 facts true at the same time. You can say that the world is awful, but then you can also say the world is much better than it was. And then you can also say that the world could be much better still. And, the example that he uses in this particular essay that he wrote was that, in terms of the world is awful, globally, 4.3% of all children die, and children shouldn't die at all, by and large. On the other hand, in the past, about 50% of all children died. So it was much worse previously. And in the European Union is kind of an exemplar of where the entire world could be. Only 0.45% of all children die. So this is an example from human health, but you can make the same kind of series of statements about any kind of environmental problem that we've been facing. And I think it's in terms of coming to grips with what the world is like. It really helps to remember that there are things that have gotten better, to learn from those things, be inspired by them, and then try to scale them, while at the same time recognizing that the scale and scope of the problem is very serious and we have no time to waste. This is what I would describe as the new conservation narrative, and these are 4 books that give you a feeling for that. One of them, Wild Hope, was actually published more than a decade ago, but in recent years, there have been quite a few, and this is just a small selection. One, Saving Us by Catherine Hayhoe, who talks about improvements in the climate and also ways about talking about climate change in using a strategy that is more likely to bring people on board and less likely to alienate them. Another, Hannah Ritchie, she's the one in charge of a lot of the data for Our World in Data, where a lot of the examples I gave came from. So she wrote this year a book called Not the End of the World, with a lot of examples for how things are getting better. And most recently, a book by a former student of ours at the Scripps Institution of Oceanography, What If We Got It Right, about solutions and visions of the future for climate change. So these are, if you're looking for examples to inspire you and learn from, I really recommend these and a variety of other books along in the same vein. And with that, I'll close and say thank you, muchas gracias, and I'll take any questions you might have.
Thanks very much, Nancy. Very interesting, and it's a very important message you are giving us. But there are many comments and congratulations for the studies and for the presentation. And we have questions from students. They are asking how are species at risk identified? How do you identify a species that is in risk of extinction?
Yes, there's an organization called the International Union for the Conservation of Nature, IUCN, and they sponsor a global red list process, which is used, and it's been, I don't remember the year it was founded, but it's been going on for a number of decades. And so they have, within that broad, species protection activity, they have various working groups. So they have a working group on corals, they have a working group on amphibians, they have working groups on birds and mammals. So they have some working groups on marine invertebrates and plants as well. Some of the more, as is typically the case with conservation, there's a lot more known about the larger and more charismatic species than about the small things that are hard to spot. But these working groups work using expert opinion and the data available to determine whether a species is endangered. And the endangered, there's threatened, endangered, threatened, vulnerable, endangered, extinct in the wild, and totally extinct. So there are various classes of level of danger. And they use things like the total population size and also the percentage of the original population that is currently surviving. So and also things like the geographic range. So there are a variety of factors that come into that weighting. You can go into IUCN on the red list and read about it, and they'll give you a much more detailed example.
Okay. Well, we have questions about protected areas and the biosphere reserves, and they ask if how do they work, and if we need more, or what is the real effect on
protecting? Yeah, we definitely need more. In fact, there's a global effort that's called 30 by 30, which means protecting 30% of the world's land and seascapes by 2030. Right now, for example, the marine areas are well below that. I actually don't remember the figure for terrestrial protection, but it's also not where it needs to be. But this was a big, the biodiversity conference last year made an enormous amount of progress in terms of getting countries together to come up with 30 by 30 framework. And now countries need to come up with the strategies that they are going to use to achieve that level of protection. So, and there are a variety of people who are sort of like red lists for species. There are people who work on figuring out which are the most endangered places on the planet in terms of ecosystems to prioritize for protection as well. So, so sort of a combination. For example, I sit on the global board of the Nature Conservancy. And a protection of land and seascapes is a big part of what the Nature Conservancy does. And they use there are a couple, in terms of where they act, it's a combination of how much biodiversity benefits a place represents. In other words, there are lots of different species or lots of different endangered species present there. And then also what kind of climate benefits does a particular ecosystem represent? For example, the potential we're using nature-based solutions like for intact forests to sequester carbon. And then in terms of immediate action, those two sort of provide a general framework, and then sometimes action is taking place specifically because there's a threat to a particular valuable piece of the planet, and so action will be taken because it's under threat of being sold and converted to, say, non-biodiversity or climate-friendly uses. So in the past, there were like papers identifying both for the land and the ocean biodiversity hotspots. There are similar papers that have identified places that are really ideal for carbon sequestration. So there have been a lot of academic studies that show where the most important places to act are, and then NGOs and governments then need to step up the plate, which they are increasingly doing, to actually take steps to make sure those places are indeed protected. And then, of course, there's this whole, as I mentioned, the UN restoration effort, decade, which is also an important part of securing both climate and biodiversity benefits. For example, mangroves, I mean, they're narrow in terms of they don't cover huge areas, say the way the tundra does, but they are important carbon sequestration sinks. They are important nursery grounds for supporting biodiversity. And they also, and I think this is very important, provide very important coastal protection benefits so that communities near the coast are much less likely to suffer in the context of large hurricanes or typhoons or even tsunamis. So they have a win-win, they're a win for climate, a win for biodiversity, and a win for human well-being.
In Mexico, we have a species at risk, is a comment, but we don't really know much. In the news, we learn about the vaquita marina in the Gulf of California, and the problem with the monarch butterfly and the mangroves. And they ask if there is a organization listing the species at risk of extinction in Mexico.
So I don't know in detail what you have available in Mexico, but I do know that there has been a lot of work done on biodiversity protection in Mexico, and there are a lot of scientists working on it. So I would recommend just doing, a very standard Google Scholar search or just a regular Google search, and because I know there's the Institute for but I can't remember the exact names of all the Mexican organizations that are in charge with this, but there's a lot of effort being made in Mexico, from everything from managing fisheries to forestry protections. Certainly, I mean, the Nature Conservancy, for example, went to the Yucatan at one point to look at various efforts being done there. So there's lots of different NGOs and then their governments, and they're all sort of working together, and also sometimes in their own veins. And as I say, I can send it to you if you post. I don't know if you post follow-up answers on your website associated with
yes, we can do it.
Yeah, I'll come up with a bit more detailed information specific to Mexico that could be helpful for answering that question.
Oh, okay. Jaime Odabachan asked about the role of the zoos, and in particular about the zoos in Europe, about the reintroduction of species at risk of extinction. What is the role of the zoo parks?
What is the role of the what? Zoological parks?
Yes.
Okay. I can't speak for Europe per se, but I can actually speak to for in the United States because I used to work I'm retired now, but I used to work for the Smithsonian, and one of the branches of the Smithsonian is the National Zoo. So I know quite a bit about what that zoo does, which is a leader, and therefore what zoos overall do. So, for example, the National Zoo in the United States has breeding programs for a variety of endangered species, but the zoos do not. There's a whole organization which coordinates the efforts of zoos, because when you're going to try to recover endangered species, you're by definition, if it's gotten to the stage where the zoo has to be part of the effort, then the numbers are very low and you run the risk of genetic inbreeding. So it's very important to have good demographic records for where these different individuals came from, so that you can optimize breeding strategies. But for example, the National Zoo was responsible for releasing oryx, a kind of I think it was a scimitar oryx, into I believe Chad, somewhere in northern Africa, and so they're now babies of this. So they were extinct. These oryx were actually extinct in the wild. There were no more of them left in the wild, but some of them were in captivity. So they created a breeding program, and ultimately oryx were brought back to North Africa. And it's now the case that these oryx are breeding in the wild, producing babies in North Africa, when before they were actually completely extinct in the wild. That's one example. If you go on the website of any zoo or even aquarium for that matter, for marine or freshwater species, you'll find examples of their breeding efforts. I mean, one example I know of, because it's so different than most of the others, is the effort to breed this what's called it's a kind of giant stick insect. It was locally extinct in an island off the coast of Australia, and they eventually found just a handful of surviving species in basically this rocky promontory jutting out of the ocean. They brought them back, they bred them. There are now colonies of them all in a variety of different places. And once the rats are removed from the place where they came from, then they can bring them back. So that's an example from insects. So it's not just birds and mammals. There are big efforts in Central America to breed amphibians in captivity, because a lot of them have been decimated by the fungal disease, which has really caused a lot of problems for amphibians worldwide. There in Hawaii in particular, there are big efforts to breed. A number of plants were really brought to the brink of extinction with the introduction of not only rats, but also goats and sheep. And so they've been breeding these plants and reintroducing them to the wild. So there are efforts all over the world to reintroduce species, and almost without exception, well, certainly without exception, when they involve major zoos and aquaria, they're done in coordination. So some zoos take charge of some species, some take charge of others. It's also usually the case that you don't put all of the individuals of one species in a single zoo. So there are a lot of efforts. I mean, this is how in the United States, for example, we have something called the black-footed ferret, which was thought to be completely extinct. A dog arrived at a farm a couple of decades ago with a dead ferret, which made them realize it was a recently dead ferret. So whoops, maybe it's not extinct. So they brought them back into captivity, and they've been breeding them. And they still have troubles keeping them alive in the wild because of various diseases and whatever. But this was a species that was, again, like the oryx, brought back from literally the brink of extinction. California condors are another example, and I'm sure there are things going on in Mexican zoos along a similar vein. I'm not as familiar with those examples. It's a real science. I mean, and I would say it's not for the faint of heart. When you've got in your hands the last 10 of something, you can't afford to make any mistakes. And there are a lot of things that can go wrong when you have so few individuals left. But there are some remarkable success stories of things being brought back from the very, very edge of non-existence.
Thanks. Salvador Valle asked about the implications not reducing the CO2 in the atmosphere, the emissions of the CO2, and what the global consequence will be, or the global implications of not reducing.
I mean, so far we haven't gotten to the point of massively reducing CO2 in the atmosphere, unfortunately, because it's still continuing to increase. What we want to do is get, the ultimate goal would be to get CO2 back to pre-industrial levels, which would result in a stable climate and therefore stable habitats for species, which I think it's one of the really dangerous aspects of where we are now, is that we have both a climate crisis, which is making, just by itself, is making very hard for some species to survive. I mean, a classic example would be the things that live on mountaintops. When as things get warmer and warmer, they're pushed farther and farther up to the top of a mountaintop, but eventually there's nowhere else to go. Or similarly, polar regions, where as things get warmer and warmer, habitat shrinks for things till the point there's no habitat left at all. But just in general, all the changes associated with climate can make it very, very difficult, can desynchronize cycles, say, between birds and the food, the insects that they eat. And there are a variety of ways that climate change is really rough on species. In fact, the big mass extinctions that we've seen in Earth history, they're not all of them have caused by climate change, but many, many of them have been caused by rapid changes in climate and species being unable to evolve fast enough to survive. So you've got that going on. In addition, you've got over harvesting on land, and particularly in the ocean, and on land, and also to some extent in coastal oceans, habitat destruction. So reducing the amount of space where animals and plants non-domestic animals and plants can live. So humans and their domestic animals and their crops take up the majority of the space on the planet, which means everything that's left is squeezed into smaller places. So you've got that alone is a risk for extinction just by virtue of reducing the population number. So you have those two different independent and interacting sets of stress factors, which is how we have wound up in the situation we are in. So in terms of reducing climate change, it will definitely help. It will reduce the immediate impacts. And then also, I mean, really, it's what you're trying to do is reduce all the impacts in whatever you can, in whatever way you can. Now, in terms of reducing the non-climate impacts, it's actually easier to do that quickly. We can protect areas, we can restore areas. Reducing CO2 takes longer, particularly since CO2, so even if we stopped emitting lots of CO2 into the atmosphere, it has a lifespan in the atmosphere, which is quite lengthy, actually. So the only way of quickly getting CO2 out of the atmosphere is to draw it down. And there are two ways you can do that. One is using nature-based solutions, for example, reforestation or protecting, especially old forests with large trees and coastal habitats. You can have nature-based solutions with carbon dioxide reduction. And then, of course, there are technologies being explored for a variety of man-engineered ways of reducing carbon dioxide emissions. The problem with those is that they're really still mostly ideas or concepts or very small scale, and they will be useful, I would say, if they are successful in a way that is not prohibitively, that both works and is not prohibitively expensive. At some point in the journey we are on, they will help clean up sources of carbon dioxide, which are otherwise hard to reduce. But really, most of the work has to be done with reducing the emissions themselves and then helping nature draw down some of the emissions that are already in the atmosphere. But the benefits will be, the question was, what will be the consequences if we succeed in sort of managing to get climate back on track? The benefits will be enormous for ecosystems and species around the world. But I think most importantly, the benefits will be enormous for us. I mean, we have seen, just in the United States, two really catastrophic hurricanes hit the southeast of the United States within 2 weeks, and they rapidly intensified from almost nothing to category 4 and 5 storms, and that's a clear signature of climate change. So and then heat waves, one of the biggest sources of human death is actually heat associated. So between big storms and heat, and then the effects of drought, and then conversely flooding from rainfall, all those things are making life on the planet much harder for people. And so there will be huge human benefits if we can manage to get climate under control as well.
Oh, thanks. Well, there are comments about the coral reefs. I suppose because you
I'm happy to talk about coral reefs.
Showing some of these very interesting pictures and what was happening. And they ask if coral reefs are at risk of extinction. What is happening? And they also ask about the coral reef of the coast of Belize and Yucatan in Mexico. If there are programs to conserve or to protect them.
Yeah, there are definitely programs to protect coral reefs around the world. And also there are quite active restoration programs. I'd say the restoration for coral reefs is actually much harder than it is for, say, mangroves. And it remains very small scale and very expensive. So coral reefs are of all the ecosystems that I know, coral reefs are probably the most challenged by the environmental stressors that are going on right now, because they're extremely sensitive to small increases in temperature. You only need water to get about 1 to 2 degrees centigrade above normal seasonal maximum in order for widespread bleaching to occur. Bleaching is the breakdown in the symbiosis between the coral animal and the single-celled algae that live in their tissues, and those algae feed the corals. Corals are completely dependent on them, and so when the symbiosis breaks down, then the corals starve to death, and if things don't get better, they die. So they're very sensitive to temperature. But as I showed you right at the beginning, at the example of Discovery Bay, Jamaica, those reefs did not collapse because of climate change or coral bleaching. They collapsed because of a combination of overfishing and other local disturbances, which made it impossible for the corals to regrow and recover. So it's been increasingly shown that if you can reduce local threats like overfishing and nutrient pollution is also bad, because essentially corals and seaweeds are fighting for real estate. So if you get rid of the fish that eat seaweeds, or you increase the nutrients in the water that help seaweeds grow fast, you wind up giving a benefit to the seaweeds at the expense of the corals. So what you want is situations which give corals a benefit relative to their competition with seaweeds. So by reducing pollution, and particularly by reducing overfishing of species that eat seaweeds, that you can definitely increase the ability of corals to recover from disturbances like that, like, say, the hurricane disturbances that happen routinely throughout much of the Caribbean, and certainly along the Mexican Caribbean coast. So reducing in local stressors gives the reefs more what's called resilience, and that helps them recover when they are damaged. In addition, it's been shown in some cases that you actually not only can corals bounce back more quickly, but in some cases, the initial mortality is also less if you have healthier local conditions. So the strategy for reefs right now is essentially reducing local stressors in order to buy time with respect to climate change. Corals themselves are also slowly becoming more heat tolerant just through the simple process of natural selection. The most sensitive strains of various species of coral and also their symbiotic algae are weeded out during these mass bleaching and mortality events, and the survivors tend to be somewhat more heat resistant. And we know that's the case in a big context, because places that are routinely get hotter have higher thresholds for bleaching than places that are routinely much cooler. So we can, that's basically basic natural selection in action over the course of the history of the reefs. So so there's a combination of reducing local stressors, depending to some extent on corals, the survivors being a little tougher than the ones that died, and then increasingly coral restoration, including not simply just replanting corals, but actually looking for a genetic variants, these survivors of major heating events that can be used to breed, to artificially increase the heat resilience of corals. Similar things can be done for actually disease resilience, which is also a big problem, particularly in the Caribbean, where major diseases have swept through. It's a big part of why the reefs of Jamaica initially collapsed, actually was a major disease affecting that branching coral I showed in one of the very beginning slides. So it's not just restoration as gardening in a simple sense, but restoration using particularly tough corals in order to rebuild reefs for the future. Restoration is, especially for corals, tends to be very labor intensive. I think it's unclear. It's still unclear whether it's going to make a major difference. Some people would argue it's going to make no difference at all. Some people say we have to do, whatever we can to sort of create a breeding stock that is more tough in the face of likely climate change. I think the jury is still out, as they say, but that it's important we only did what we knew we'd work. There are a lot of things that are around now that we never would have tried. So there's always room for sort of a combining strategies that we know will work with also working to some extent on things that we just don't know that are high risk, but potentially high reward. So I'm hopeful that some of these restoration efforts will play a role in keeping corals around. I mean, I think the most critical thing is to prevent extinctions, to be honest. When you've got reefs down to say 5% living coral from when they were 60, 70% living coral, what you really want to do is keep all the pieces in place and prevent extinctions, and keep, to the extent you can keep local pockets of reef relatively healthy in, say, places that are less vulnerable to big temperature increases. Some places have cold water upwelling, which gives them a little bit of protection against global warming. So you just need to have all of these, and then there's restoration. I mean, in the not so much in Mexico, but certainly in Southeast Asia, restoration against very destructive forms of fishing involving dynamite or cyanide. So you just want to keep as many pieces in play as possible, with the idea that, 10, 15 years down the road, we will have addressed climate change. And we'll be on the road to recovery in terms of the climate. And then you have the pieces that will be in place. I mean, and so you really want to avoid extinction. Reefs themselves are not going to be like they were when I was a grad student for the foreseeable future. But if we have all the pieces in place, they have the potential to get back to that stage at some point. And so to me, that's part of what we're doing. It sounds a bit in many ways, the strategies are what we've used with agriculture and breeding of, crops and animals. So it's just that there are many more people involved in the effort to genetically improve disease-resistant crops and that sort of thing than people working on the same kind of problem for coral. So we're starting much later than the people working in agriculture are starting. But I'm a big believer in keeping some high risk, high reward options active, even though a big chunk of the money really needs to be reducing local stressors and addressing climate change, which are both things we know will work.
Okay. Santiago Luna comments that there are documented cases in which getting rid of the stressors in the coral reefs permit that they recover.
Yes, I mean, a good example comes from work done in Curacao, which showed that Curacao, I'm sorry, not Curacao, Bonaire, it's actually next to Curacao. In Bonaire, they've had a national park for a long time. They actually support the national park with fees, like tourists come in from outside of Bonaire. They have to pay a fee, which goes to support the conservation activities in the park. They banned fish traps. They banned fishing of seaweed-eating fish. They've done a lot of things to protect the health of their reefs. And Bonaire actually, interestingly, doesn't get hurricanes very often, but it did have a hurricane and then a bleaching event. And the two occurred really within about 2 years of each other, and it resulted in a dramatic decrease in the amount of coral and a dramatic increase in the amount of seaweed. But in Bonaire, because the reefs themselves are locally reasonably healthy, what happened over time was after these two disturbances, the corals bounced back and the seaweeds declined. It's a never-ending sort of effort. It's not, you never saw, as sort of what I was alluding to before, you never really solve conservation. You have to keep working. New things happen. It gets harder. You have to, develop new approaches or amplify the approaches you've been using. So it's not like Bonaire has everything solved, but they are a very clear example of how reducing local stressors provides resilience to larger scale disturbances like heating events and hurricanes, which people can't control.
Constantino, do you want to make a comment or a question?
Well, yes, thank you very much. It was fascinating. I myself have been most of the last few years a doom type of person, and I inevitably see the things very bleak, in part because I believe that some of the positive examples, several of the ones you mentioned and others, may be just a bit like what is happening with global warming, that global climate change is not just everything warming homogeneously. There will be places that will have nicer weather under global warming, but the general effect is going to be less predictable, mostly negative. And I wonder whether there are some pockets where you can have these good news developing, and whether they are transient. I'm going to give an example of what I'm thinking of. We have Sargasso problems in the Atlantic, and we know those are generated away from the places that are being affected, like, for instance, in the discharges of nutrients in the rivers of the developed world. Now, if those do not change, there is going to be sargassum in the Caribbean and further down in Brazil and perhaps even in Africa, in West Africa. We don't have yet a similar problem in the side of the Pacific. So Cabo Pulmo may be allowed to be a success because it's not facing yet one of those problems. It has not arrived. But I wonder whether an initiative like Cabo Pulmos would ever work in the places where Sargasso is going, even if there is the local intention and local measures placed there, because the global problems are come from abroad. And I'm going to make just a little parenthesis because I forgot to mention in time that a nice example of reintroduction from zoos, from European zoos, is the Przewalski horses that were reintroduced after 200 years in Kazakhstan. And so I just wanted to say that because otherwise I would forget, and that's a question of the public. And that's it. But yes, so that is my worry about this. And of course, the worry is also whether we may become complacent if we emphasize the good examples. And then, of course, some tycoons from oil companies would come and say, you see, there's no problem. So anyway, this is the bleak view.
Well, you're hardly the first person to mention the possibility that talking about what's working will get people complacent. And in fact, there is some element of that. You have to always couch it in a way that people can't get complacent, because complacency is definitely not something we can afford right now. On the other hand, if it's definitely the case that if all you do is talk about how hopeless and horrible things are, people tune out. They do not get inspired to act if they think there's nothing they can do. It's well known by social scientists for decades that people need a sense of what they call agency in order to act. And so if people don't have any sense of agency, they will do nothing and the problems will get worse. Not only that, as I mentioned, the successes have important lessons. Successes combined with the failures. For example, the failures can tell you what not to do, but the successes can tell you what worked. And for example, in marine protected areas, one of the key lessons is how important it is for local communities to basically have ownership of conservation efforts, because if they don't, it becomes something imposed from the outside, and essentially you wind up with a paper park. That's what really distinguishes Cabo Pulmo, of course, is driven from the bottom up. And that's itself generates a certain kind of tension, because whereas it's really easy to have dictates from, you can say the central government, needs to make a law and then everything will be fine. But if no one pays any attention to the law, then nothing's fine at all. And yet having to work from the bottom up takes more time than it does to work from the top down. So there's this constant tension of trying to get things done quickly and broadly versus durably. And I think you need both. And it will take, ultimately, I'm not naive. It will take real effort to sort of change the kind of what I would describe almost as the global mindset of people. We can't keep doing things the way we've been doing them for the past 100 years for the next 100 years. We're going to have to find some combination of a different technical strategies with different mental strategies, I guess is how I would put it. And there are certainly places where successes are more likely than others. I agree with you. I'm not sure if I would attribute. Bonaire. Actually, I don't know what the sargassum situation is. Bonaire. And in fact, the reason for these sargassum blooms is in fact still debated by scientists. It's not entirely clear that it has to do with nutrients in rivers. It may have something to do with sort of a regime shift in the currents, which just got these populations of sargassum established in a new location, which then wound up constantly feeding them into the Caribbean. So for sure, some places are more promising than others. Some places are more promising physically or biologically. Some places are more promising socioeconomically, for that matter. Certain cultures have a kind of we're in this together, let's work on it together sort of element, and other cultures are more sort of individualistic and whatever's good for me is what I want. And I think we need more of the former and less of the latter, and places that have that already sort of as part of their cultural way of doing things, I think are going to do better. I think that's why there's been so much focus in conservation now on indigenous communities and local communities, because they are connected to place in a way that makes them sort of, especially in a lot of indigenous sort of social structures are set up for resilience and durability over long periods of time and community effort. So those kinds of cultures are going to have an easier time of making this transition, I would say. So there are enabling conditions, as they call them, both biophysically but also socioeconomically.
Yes, thank you very much. Yes, that is basically my comment, Nancy and Jaime. Of course, there the global problems, also the socioeconomical global problems are something that has to be tackled. I was thinking, as you were talking about the electric cars, of these new worries in Canada and in the US about the invasion by Chinese electric cars. Now, we need electric cars. We do. And that is recognized by the governments in Canada and in the US. Yet there is a source of electric cars that is likely to be blocked because of reasons that may be genuine. But that shows the complexity of the problems in a planet where we are actually very, very many indeed. And I think when you mentioned just now that we cannot just be behaving as we have done it in the last 100 years for the next 100 years, and mainly that must apply to reproduction. I think we are in an enormous number, and to reconcile all the demands of our enormous numbers with all the expectations and all the requirements of nature, I don't think it's possible.
Well, actually, I mean, conservationists don't really like to focus on population because it's really, the problems are of population, but also consumption, per capita consumption. But I will say, in terms of population, in fact, the biggest problem, it's really per capita consumption that is a lot of what's going on. But it's also the case that economic well-being leads to demographic transitions and drops in fertility. And so I actually think that problem is, to some extent, I mean, there are a lot of countries where people are, where government leaders are saying have more babies because they can't figure out how to make that demographic transition work. But women are making decisions that, my children are going to survive. I don't want 12 of them. So, that to some extent, the demographic transition, I think, comes with increased economic and social well-being. So I'm, in some ways, all of the, much of this is like getting through a bottleneck. So it's population/consumption. It's the ability to take advantage of, I mean, even wind energy is basically solar energy. So to sort of transition away from fossil fuel to the enormous amount of energy that is created by sunshine and all of its manifestations. So we make that energy transition. We become more efficient, and but it's going to take time, and so it's kind of a process of minimizing the damage until we get onto the other side of that bottleneck, so that we have more to work with when we do emerge.
Yeah, right. Thank you. Yes.
Thanks, Cosentino and Nancy. Well, it's a very complex situation with no simple solutions.
There are no silver bullets. Silver bullets. But there are bullets out there, to use a bad analogy. There are ways, that there are solutions.
Yes, that's the message. We need to keep doing research and understanding better what we are doing and how the ecosystems react. And I'm told that we keep getting comments and questions, but we are approaching the end of the seminar. We will send the comments to Nancy.
Yes, please. I was going to say, if there are any specific questions that I can address by getting them back to, taking a day or so to look through them. And as I say, I will try to find out more information about the biodiversity protection strategies in Mexico as well.
Okay. Well, thanks very much, Nancy. Very interesting and very interesting research you do. And we have a question from students asking how they can contribute and what is the role of the universities. But we can address this later. Thanks very much. Yeah, as I mentioned at the beginning, we look forward to see you in Mexico soon.
Excellent. Thank you very much for inviting me. I enjoyed it.
Well, thanks. And thanks to both thanks for the comments and the questions. And we invite you to keep joining us for the next conferences.
Excellent.
Thanks very much. And thanks, Constantino. And thanks to all of you. Muchas gracias a todos y pues les reiteramos nuestra invitación para que nos continúen acompañando en este ciclo de conferencias que hemos abordado pues muy diferentes temas a lo largo ya de 4 años. Muchas gracias.
Muchas gracias.
Muchas gracias. Gracias, Nancy.
Chao.
Chao.
Asignado en la opción señalada, institución de asignación UNAM.
Sí quedé.
El sueño se cumplió. Ahora formas parte de la comunidad universitaria y puedes acceder a las becas que Fundación UNAM tiene para ti. Conoce nuestros programas en www.funam.mx y en nuestras redes sociales.